Now, this sampling techniques is something that comes in between the research process. If you consider, this is somewhere a step, about a sixth step or a seventh step. We name this as a sampling design, and under which, where there are 5 basic steps. That is, to start up to identify who exactly are your target audience, how do you decide about your sampling frame, how exactly you understand to design the methodology of picking up the samples, and then moreover, lastly, the important topic of what is your determination of a sample size, right? So we will have a discussions about the same. And in the second part, we will be talking about an empirical tools for the data collections. Now, once you get an idea about who are your target audience and how exactly you have to pick them in the field for your field work, right? So you have to plan your field work much before the sampling design, right? So what kind of a methodology that I can adopt? So what is the tools that I'm going to use for the collection of a primary data? Now, what I have done here is in 7 to 8:30, I will be talking about the qualitative tools and as well as the quantitative tools, right? For in the point of a primary data collection, quantitative data, keeping a quantitative data into consideration, what kind of a tools one can adopt to collect the data. And at the same time, for a qualitative type of a research, if you have to adopt a qualitative data collection, then what kind of a tools that one can utilize it, right? So this is more or less a theoretical concepts that we're going to talk about. In case you do not understand certain the topic that I'm going to discuss, you can make a note of it, and at the end we can have the discussions, right? So we'll begin with a certain first simple topic, that is a sampling design or sampling. Now, let us assume that a researcher wants to study how stress impacts the examination in the life of a college students in India. Right? Now, assume that a researcher wants to do this study. Now, to do this research on this particular topic, first of all, it is important for a researcher to meet the respondents, right? Now, who are the respondents here? The respondents here are definitely a college students, right? Now, since we're saying that the definition here, it is to study the impact of stress on the examinations in the life of college students, right? The respondents are the college students, but the college students of an India. Now tell me, is it feasible for a researcher to interview every single college student in India? Is it feasible? Practically, is it possible? No, right? So practically, it is not possible for a researcher to interview every single college student in India, right? Now, to do this, what exactly is required? Generalization is required. To do the generalization, what a researcher has to do? He has to take a small unit of samples, study the small units, and obtain the results for the small units. And these small units, or we call it as a sample study, and then those results has to be generalized to the population. So this is the process which we are talking as a second branch of statistics called as a statistical inference, right? So this is a statistical inference. Now, to know all this funda of your research, as a researcher, one must firstly understand to know what is the type of a data that you're going to talk about. At the same time, whether the data that you're dealing is a population or a sample, right? So first, get a clarity on the concept, what is the population data and what is the sample data. So this is very, very important. Once you do not have the clarity of whether you're doing a population study or a sample study, because a population study, something is called population study in general is called as a census, whereas a sample study in general is called as a survey, sample survey, right? Now, there is a distinction between both. So one must understand what type of a data that you wanted and what type of, whether your data that you are taken is from the population or from the sample. Now, having said this, to know all these things, first, as a researcher, one must know the language of a sampling design. Now, tell me, what can be a language of a sampling design? You can type it in the chat box. What can be the language of a sampling design here? What concepts can come under the language of a sampling design? Anybody? Any idea what can be? I said you, if you have to talk about a sampling design, there are certain things as a researcher you must know, right? So what can be the concepts that can come under sampling design? You can quickly unmute yourself and talk.
Karinakshi Suvarna said sample frame.
Sampling frame, okay. Elements, somebody saying elements, representative units, good. So first and foremost thing, one must know to define a population. Secondly, one must know what exactly is a sample. One must also know the difference between a parameter and a statistic. And one must also know what is observation and what is element. Now, as a researcher, today we have a tendency to outsource the data analysis, right? I'm sure many of you tend to do it because you feel that this is not your area of this is not your cup of tea. This is not an area. This is an area where exactly you have a lot of fear of numbers and so on, right? Understandable. But as a researcher, if you have to design your research methodology chapter, under which a sampling design is one of an important concept, you have to know these basic 6 important terms in sampling design, right? Now, firstly, let's understand what is the difference between a population and what is the difference between a sample, right? So population, as all of you know about it, it is a set of all items or an individuals of an interest to us study, right? The population of our data can be as large as millions and billions. At the same time, it can be as small as tens and hundreds also. Now you may be wondering how the population size can be tens or hundreds. Consider an organization where you have only 36 employees. Then that's a population itself, right? It's a smaller populations. But always in a research, we tend to use a population size as denoted as a capital N. The complete enumeration of a population, we call it as a census, right? Now, if you have to take an example of understand an example of a population, the human population of an India is a population. The total number of BMW cars in Mangalore is a population. The number of light bulbs manufactured in a factory on a particular day is a population. All registered voters of our country is a population. People having an Aadhaar card is a population. People living in Mangalore is a population. Number of workers working in MRPL or a population of an income taxpayers in India. So this is generally considers all units of a study. So this is a population. Now again, coming back to my initial step, right? The first query that I have placed it, how stress impacts the examination in the life of college students in India. So what is the population here? What is the population here? Can I get an answer? Quickly type it in the chat box. How stress impacts the examination in the life of college students in India. So if you say students, they are my elements. They are my sampling units. I'm asking about a population. See, you need to bring the clarity between the terms that you tend to use it, right? So what exactly is the population here? College students in India. Yes, the population here is the entire college students in India. Now one must understand, is it feasible for us to study this entire population? Absolutely no, right? Is it feasible? How many college students you will? How do you define firstly an operational definition of a college student, right? So there is a lot of clarity that needs to be brought before we decide a certain topic like this, right? So once you decide your topic, you have to bring the clarity on every single terms. So here the population is entire college students. Now let's get back to something called as a sample, right? Now you know what is population. So what is the sample? Definitely a subset of a population, right? But understand your sample should be a representative of a population, right? You cannot say your samples are samples, but you also have to define the populations in your study, and the sample should be from the population. So that's why we say they must be a representative of the population. Now, sample size are always at least one less than your population, and we denote the sample size by statistically letter small n. Now you may say that why it is capital N, why it is small n, and so on. These are certain terms that we tend to use it in statistics, and that's why we have to bound to be keeping the notations as same as it is. Now, sample is a smaller, manageable version of a large group, right? So this is a simple understanding of what is sample. Now, the blood samples collected for inspection, right? Nobody takes up a 2 liters blood from your body for diagnosing any kind of a disease or any kind of a test, right? It's a small, about a 10 ml or 12 ml is something that is taken, and therefore it is a sample study. Now, if somebody comes as an inspector, that is the quality inspector to my company, if my company manufactures a light bulbs, right? So nobody has a time to look into all the samples that is produced on a particular day. So even the quality inspector will pick up the few samples and test the quality of the product. So 1,000 voters selected from a Mangalore. There may be billions and trillions, right? But still we are taking only few of them. So that is the samples. Then food samples selected for testing, right? Suppose if anybody is pleased with my lecture and you call me for a dinner, and if you have to please me with a good recipe, what exactly you tend to do? You will try to taste it, right? You will not take everything on your plate and start eating it, right? So you will try to taste at least a spoon of it, and then taste it, and then based on the taste that you have done, then if you want to add few flavoring agents or not, that is up to your call. So, but what we do, we take few items. So that is nothing but your sample. Grape testing. Suppose if anybody wants to buy a grapes, right? What is a common tendency each and every one of us have it? When we go to a market, do you take a permission of a person to pick up one grapes from the basket of grapes that the merchant has it? You try to take one and put it inside your mouth. Now, why do you do this? It is not that you're very fascinated to have a taste of grapes, right? You're trying to taste a grape so that to make up a decision on how much quantity that you want to buy, right? Suppose if the grapes turn up to be very sweet, then definitely what you have thought, you will tend to increase your purchase. The grapes that it tends to be very sour, then you make a decision not to buy as well. So one grape is sufficient enough to make a decision, the decision of whether you have to buy in more quantity, less quantity, or absolutely no buying. Then sample of blood tested for the this or a swab test, right? Or some simple example of a day-to-day life. How do we cook rice? We take 1 grain of rice and we test the grain of a rice, right? If a grain is cooked, then we make an understanding that the rice is cooked, right? 1 grain is sufficient enough to make a decision on all the grains that is cooking in a. But now today, of course, we tend to use a cooker. But however, in real life, we tend to use these as a sample studies. Now, let's say if somebody wants to make a study on job prospects of an MBA students of a Mangalore city. Now, what do you say about the population? I asked earlier about the whole of India. Definitely, it is an MBA student of a Mangalore city is a population, right? Now, as per the discussion so far, you will tell me the population is definitely an MBA students of a Mangalore city. But can you give me a small difference? Is this MBA students of a Mangalore city a real population, or can I call it as a universe? Is there a difference between a universe and is there a difference between a population? What do you say? Are you all with me? Yes. Okay. Thank you. So is there a difference between a universe and a population? Target population. Yes. Okay. Tara ma'am, can you just tell me what is the difference? If you said yes, there is a difference between a universe and a population. What is the difference? Any quick answers? Okay. So let us firstly understand there is a distinction between universe and the population. Now let's understand how do we differentiate between a universe and a population, because generally when you consider the population and universe are used synonymly, right? So people tend to use it, universe is population, population is universe, but there is a difference. Now let's understand what is the difference. Now who are my target audience? MBA students, right? Now let's say if I'm targeting an MBA students of a Mangalore city, right? Now suppose if I'm saying the colleges if I'm targeting a MBA colleges in Mangalore, you see every MBA colleges varies with their seats, right? Say, for example, a St. Aloysius College, where I am as a professor working. So in my college, we have 240 seats kept for an MBA. Some other colleges have 120 seats. In other colleges have 60 seats, and so on. If I consider the total number of MBA students in a graduating per year, then the roughly, if I take a 240 plus 120 plus 60 plus 60 plus 120 and so on, roughly, let's say 2000. This is universe. Did you understand this? This is universe. Now, can I consider universe and population as same? Is every time we get 240, if our college intake is 240, can we say always we get 240 students completely? No, right? So say, for example, in a particular year, we get admissions of 232 students, or in out of 60 students, there are 53 students only. Out of 120, there are 117. And roughly when you take a total, right, if you assume that 2000 seats are allotted for an MBA, but there are only 1167 students studying in Mangalore. Now tell me, my study will be related to the universe or my study will be related to population? Tell me here. Definitely, if I have to pick my students, right? If I have to pick my students for my study, I have to pick them from the population. Now, did you understand the difference? We say the universe is the overall collection of data, and population is something where the study gets a generalization, right? So the study gets a generalization for the population data, not for the universe. Now, in general, can I say my samples are always derived from the population, not from the universe, right? It's always derived from the population, not from the universe. So in general, we can say that population is always a subset of a universe and the sample is always a subset of a population. But sometimes, a very rare cases, your population items, the total number of items in the populations can also be equivalent to the universe, right? It is not that your population need not be equivalent to the universe. It can also be equivalent to the universe. Now, having understood this concept, right? We can define universe as the total items or a collection of elements, population as the total number of items from which the information is desired for an interest, and the sample is a subset of a population for which we make up a study, right? So this is the general concept. Now, suppose if somebody wants to study say work-life balance among the school teachers of a Mangalore city. So universe, I'm just giving an example, universe, all school teachers of a Mangalore city is my universe. Now, if I'm saying the total, right? If I'm saying the total on a particular study period, or we call it as a reference period of my study, it is 1,850 school teachers of a Mangalore city. Then my sample has to be derived from my population. So if I say 10% of my population, so 185 school teachers of a Mangalore city. So this is how exactly the circle of an understanding of sampling theory is all about. Now, proceeding further, the types of population, right? Generally, based upon the countable manner, we have a finite and infinite population. Based upon the researcher's reasonable access, we call it as a target population and accessible population. And based upon the existence of the population, we call it as a real population and the hypothetical population. So generally, we concentrate on an accessible population here, right? So general, any type of a social science research or any research, we target on an accessible population, because of course we require a samples and the samples should be accessible and that should be from the population. So we normally take a consideration for our study from the accessible populations. Now, based on the countable manner, we have finite and infinite population. I don't have to go in detail. You know, all of you, what is finite population? Something that you are able to count, right? Where exactly the numbers are fixed and you know the numbers. So you are able to decide the number of units in the population. Then it's a finite population. For example, the number of students in a St. Aloysius College. We have a database. We have a sampling frame. So wherever the sampling frame exists, right? Sampling frame is a frame within which you are able to get an details of the sample sizes, right? So, or a sampling units. So, if your sampling frame exists, then it's a finite population. And if a sampling frame does not exist, then it's an infinite population. For example, number of cells in the body of a human being, or a germs in the body of a malaria patient, number of stars in the sky, or a number of cigarette smokers in a Mangalore, right? Number of a soft drink lovers, right? You cannot have a database where exactly you can get an idea of all these things, right? So this is termed as an infinite populations. Now, why this is important? Because if you have to go with the last step of your sampling design, that is determination of a sample size, one must be aware whether your sample size comes from the finite population or an infinite populations. Now, having said this, we define two other types of a population as a target population and accessible population. Target population and an accessible population. So as the word itself says, the target population is an actual population to whom the researcher wishes to target on or wishes to draw the conclusion from, or where to which the researcher wants to generalize the study, right? So ultimately, we are doing a survey to generalize it to the whole of the population. So here, if you want to generalize your sample study to the population, and that population will be called as a target population, right? Now, what is accessible population? The accessible population is a subset of a target population to which the researcher has a reasonable access. For example, all people with AIDS in Mangalore city area, right? Based on a researcher's access to which unit of a population the researcher is able to access, and that's called as an accessible population. And general research in social science, we normally consider a accessible population rather than the target population. Target population is definitely there to reach out, but generally we target on an accessible population and we try to make a study. Now, based on the existence of a population, we have two other types that can be defined, something called as a real population and the hypothetical population. The population consisting of an items which are all present physically is called as a real population. See, sometimes what so happens is the database says something and then actual what is it is different, right? So if you have if an organization says there are 52 employees in the organization, if all those 52 employees are really present in the organization, then we call such populations as a real populations, right? So this is what exactly is a real population. And hypothetical populations. So hypothetical populations are all those populations which consisting of a results of a repeated trials. For example, tossing of a coin. You know that the coin can result with two type of an outcomes, head and a tail. But a researcher is not confirmed whether the outcome will be a head or a tail. So this is what is called as an hypothetical population. Generally, we don't tend to use this in our social science research, but for a knowledge, you should know there can also be a population defined as a hypothetical population. Now, apart from these six, people term the population as a study population, the small unit population, sampling unit population. There are various other terms which are synonymally used for the types of populations. Now, survey. Right? Survey. Now, why are we talking about a survey now, right? So when we know that we are considering a population, the complete enumeration of a population is what is called as a census study. And the part of a population, if you're considering and then you're making a study, then we call it as a sample study, right? Now, census study has its own limitations as well as a sample study also has its own limitations. Now, when a person can go for a census study, now when you consider your population is small, feasible, accessible, then you can always go for the census study, right? Now, but understand that if your population size is quite large and if you have enough resources, then definitely you can go for a census study. But because whenever we tend to do any kind of a research, the two basic limitations which every researcher has is a budget and a time, right? Keeping these two constraints into considerations, we tend to define a study as a census or a sample study, right? So when we are not able to enumerate the entire population, we go for a study called as a sample study, right? Where we try to take a samples. I always, again and again, I will tend to repeat my words, samples who are the representative of the population, right? Say, for example, if I'm doing a, if I'm interested in doing a study on income and saving habits of a fisherwoman in Mangalore, right? Since my college is next to a Kerala border, and let's assume that I am coming from a Kasaragod every day to work in St. Aloysius College. Now, if I want to do a study on fisherwomen in Mangalore, what's the definition of a fisherwoman? The operational definition of a fisherwoman is that anybody who's involved in a buying and selling activity of a fish, right? Now, this is a definition of a fisherwoman. Now, since I do come from, say, Kasaragod, if I assume that I come from a Kasaragod every day to my college and I don't have a time to interview a fisherwoman in Mangalore, and next to a Kasaragod, next to my house, I assume that there is a market and I interview the Kerala fisherwomen, keeping the definitions in mind. Now tell me, my study is complete. Are the Kerala fisherwomen representative of my population? Right? They are Kerala fisherwomen are a fisherwomen study. Yes, you can get a study on income and savings habits for the fisherwomen. But as per my research or as per my synopsis, I have said that I am studying income and saving habits of a fisherwoman belonging to the Mangalore region. So my study has a samples who are not belonging to my Mangalore region. So that's why they are not a representative samples of my study. So whenever somebody is considering a sample study, your sample should be always a representative samples of your populations. Now, once you know your samples, you can easily study the samples, draw the conclusions or a data analysis for the, or a findings for the study, and then whatever the conclusions that you get it, you can generalize it to all the people in the population, right? So for this, again, it is not easy. You cannot say, I will interview only 5 people of fisherwomen, study them and generalize it to all the fisherwomen. There is some reasoning. If you understand there are 10,000 fisherwomen in Mangalore, what is the reasonable samples I have to consider to make my study generalizable? So these are the certain things one must understand. Now, having understood this, when each method is appropriate, when census is appropriate, when sample is appropriate. So now that you know the difference between a census and a sample study, census study is applicable. It's not that it's not applicable, right? It is applicable, but when it is applicable, when you understand your population size, that is your capital N is small, right? When your capital N is small. Suppose if your small capital N is large enough, then it is always advisable to go for the sample study. And at the same time, if you have an extensive resources, right? Suppose if there is some sponsored research, if you have there is enough budget and time to do the study, then of course you can go for the census study. But when you have limitations with time and the cost, it's always better to go for the sample study, right? And if suppose a researcher is having an interest of gathering an information from every individual, then of course you can go for the census study. Then if the population is homogeneous, then always it is better to go for the sample study, right? And also when you think that the census is absolutely not possible, preferably the solution is a sample study, right? So this is an idea when exactly you should go for the census and the sample. Now that we understood what is population and sample, we'll now understand the term, parameter, and the statistic, right? So you should have the clarity of a population and sample to understand the term, parameter, and statistics. Now, before this, you must also know what you mean by variable, right? I'm not going in detail introduction to the variables. But in general, I will tell you, what do you mean by a variable? What is variable according to you? Something that varies, right? Now, we are about 133 people in this particular group. Are we all same with our likings? Are we all same with our perceptions? Are we all same with our satisfaction? with respect to any units, right? We are not same. We are all unique, right? Even when you talk about a skin color, hair color, or a body mass index, height, weight, we are all different, right? Something that varies from one entity to another entity is what is called as variable. And a simple example is a height. A class of 10 students, right? A class filled with 10 students, even a twins, when you consider, there is some form of a variation between them, right? They may look alike, but the likings, the dislikes, there is some form of a variations in their body or a color or say body mass index. There is a variations, and this is what is called as a variable. Height, weight, temperature, pressure, time, and so on. So in general, variable is defined as anything that has a quantity or a quality that varies, right? So this is what exactly is the variable. Now, having understood a variable, let us get an idea of what is parameter and a statistics. Now think in this terms. Population starts with P, sample starts with S, right? So your parameter starts with P, statistic starts with S. So now understand, P for P, yes for yes. So simply a measure used to describe the population is what is called as parameters, and measure that you are using to describe a statistics is what is called as a statistic, right? So measure that you are using to describe the sample data is what is called as a statistic. So in general, parameters are always a summary measures of a population. For example, your population size, population mean, population variance, population standard deviation, population proportions, and all those things. So these are nothing but parameters. To give you an idea, say, let's say I have a company manufacturing a so let's say I have a company manufacturing a light bulbs, right? So if my day's production is say 20,000 is my production, so this is nothing but my parameter. If I say my average life of a bulb is about 5 years, right? So that 5 years is coming to all the bulbs. So I'm generalizing it to all the bulbs. So it is a parameter, right? So and in my manufacturing process, 5% of my bulbs can be defective. So I am saying this is for all of the population, right? So that is my parameter. Now, did you get an idea about what is parameter? P for population, P for parameter, right? So this is the basic understanding. But in reality, do we always know what is a population parameter? We will not know what is population parameter, right? True population parameters are unknown. So we tend to estimate these through the sample data, right? So parameters are always studied from the sample data. Parameters get an approximation from the sample data. Let us assume a population, human adult population of India, and we consider a variable as a height. Now, average height, if I decide it, that is my parameter. Average height of an adult Indians, if I say, that's the parameter. Bulbs manufactured in a factory, if I consider it as a population, and if I take a variable as a lifetime. Why I should take a variable as a lifetime? Why lifetime is a variable? Because it can vary from one bulb to another bulb, right? So that is an entity which varies from, it is a characteristic which varies from one bulb to another bulb, that is from one entity to another entity. So this is called as a variable. And then a parameter would be a median lifetime of the bulbs, or the maximum lifetime, or a modal maximum. Mode is a maximum life, right? So modal lifetime of a bulb, or an average lifetime of a bulb. So all these are nothing but the parameter. Now, having said this, what is statistic? I said S is for sample, S is for statistic, right? Summary measures of a sample data is what is called as statistic, right? Summary measures of a sample data is what we term it as statistic. Now, what can be the summary measure? Sample size, sample mean, sample standard deviation, or sample proportions. Let us again come back to the same example. My company manufactures 20,000 bulbs in a day. I am inspecting 200 bulbs for my study. So 200 is my statistic, right? For 200 bulbs, when I inspected, I have got an average life of three years, right? So that 3 years is a statistic. Now 200 bulbs, out of 200 bulbs, there are 18 bulbs were defective. So that bulbs is nothing but that 18 is what is called as statistics, right? So there can be different statistics for a different sample data. Now what is an understanding for this? Now let's say I said my day's production is 20,000 bulbs, right? 20,000 bulbs. I am taking only, say, let's say the first sample I'm saying taking is only 1,000 bulbs. Now like this, how many times I can take? The first 1,000 will give me a different average. The second 1,000 will give me a different average. The third 1,000 can be giving me a different average, and so on, right? So that's why that is called something called as a sampling distribution, where you can always have a different statistics for a different set of a sample data, right? But however, they can be used to generalize a study for the population. Why? Because these are a representative samples of my populations, right? Now I have taken an same example in terms of a Tekli tea here. Suppose if a company manufactures a Tekli tea and he claims that his net box weighs up to 350 grams and the price of a Tekli tea is rupees 500 per box, right? And the day's production is 10,000 boxes of a tea. Now the investigator wants to know, does the tea box manufactured actually weighs up to 350 grams? Now how the inspection committee can look into this, right? Can an inspection committee can come to this company and inspect every single boxes of a 10,000 boxes of a tea? They take one box, measure it, check whether they are equal to 350 and certify and pass it on. Can they do that? Can they do? Is it feasible for them to do it? No. So, but is it feasible for them to take the boxes which is given by the producer? Again, it is not possible. Again, it will be a bias. So, as a quality check inspector, what is supposed to do? Out of 10,000 boxes, he has to pick something called as, what's a term? What is that term? Out of 10,000 boxes, if I'm saying I have to pick, say 1,000 boxes, how do you pick those 1,000 boxes? Yes, of course, it's a sample. But how do you pick the 1,000 boxes? Something that I give to the randomly. Yes. So this is a term that I needed it, right? So you have to pick those 1,000 boxes on a random fashion. So to pick the 1,000 boxes in a random way, you have 10 different methods, or generally we have 8 different methods to do it. In 8 different methods, you can pick those 1,000 boxes from the 10,000 boxes, right? See, look into the beauty of a statistic. Simply, you come and whatever you see in the front, you take it and do a study. That's not the method of doing a quality check, right? Now, let us assume that the population is 10,000 boxes because it's a day's production. Now, what's a parameter here? Why do I call this as a parameter 350 grams? Because this is the claim of a company where the company is saying that I am manufacturing a box, Tekli tea box, which weighs up to 350 grams, right? Now assume that if you are a purchaser and you have purchased this 350 grams Tekli tea by paying 500 rupees, and once you come back home and you find only 50 grams in it, right? You have received the defective box because box looks big, right? So if you see after coming home, the content in the box are say 200 grams that you have received it. So as a customer, what will you do? Will you say that it's okay, who will go back? Will you do that? What will you do? You will just take the box back to the shopkeeper and demand for the replacement. Yes or no? This is a common tendency of a customer. You as a customer or I as a customer, when I'm paying a 500 rupees, I expect a 350 grams of a product in because that is what the company claims. But if the company claims 350 grams and company gives me only 200 grams, definitely I will go back and I will demand for the replacement, or I will demand for the exchange, or I will demand for the refund, isn't it? This is a common behavior. Now let's assume this box can hold up to a 500 grams of a quantity, but the company says it is giving a 350 grams. But when you come back home by paying 500 rupees for this, and you after coming home, if when you check the weight of the box, if it is about 390 grams, you're getting 40 grams more than what exactly the company is claiming. Now, as a customer, will you go back and say, no, I have paid only for 350 grams, 500 rupees. So 40 grams amount is not paid. Will you do that? Is there anybody in this group does that? You will keep quiet. Yes, definitely you will keep quiet. But in turn, what happens to your perception of this particular brand? Your next purchase also will be the same Tetley tea. Yes or no? Is it not the next purchase also you will buy the same Tetley tea? Exactly. This is what is a human behavior. This is what is a consumer behavior, right? So once you tend to get more, you have a tendency where exactly you not that you will get the next time also you will get the same thing, right? It is not that every time you will be lucky enough to get 400 grams more, but nobody brings and checks it also. That's another thing. But I'm just telling you, understand the concept of population and parameter. Company claims 350 grams. If a company claims 350 grams, company is promising the customer that he's giving a 350 grams, then they have to give 350 grams to make a profit, profit on a product or to be in the market, right? Suppose if the company says that a company is giving a 350 grams and company cheats the customers by providing a 300 grams, 280 grams and so on, in the long run, the company will shut down, right? In the long run, the company will not make a profit because the customers, once they're dissatisfied with the product, they will never buy the product again. So that's why you have to be very clear. If you are manufacturer, you have to be clear about your claim. And that's why population and parameter is very important. And that's how a parameter plays an important role. Now, to understand whether the consignment, if we have to accept a consignment of a sample boxes, whether it is confining to the 350 grams, we make a sample study and we take the sample study from the populations only. And let's say 1,000. Why did I say 1,000? Because a general thumb rule is that you take always a 10% of your population and we take 1,000. Now, 1,000 boxes are inspected. For every box, you check the weight. The first box, say 349 grams, assembly line process or a perfect process. Though we talk about 6 Sigma, 0 defects and so on, there can be variation about 1 gram or 2 grams. Why? You're talking about a tea. Tea has its own density, right? The tea powder has its own density. Now, when there is a variation of 1 or 2 grams, right? So you need to make a record of it. So one box you check, it may be a 349 grams, second box 352 grams, third box 349 grams and so on. Now, when you take a sum total of 1,000 boxes, should that 1,000 box sum total, the average, should be equivalent to 350 grams? Of course, right? Suppose if it is little more than 350 grams, still you can accept the consignment and send it to the market. But when you take 1,000 boxes and if your total is coming up to say 330 grams, you should check there is some problem in your production on that day and those boxes cannot be confined to the standards. That's why we have in productions, in quality check, there are a lot of methods to see whether how much of a percentage error that you can accept in your research, right? So this is what exactly is your sample study, right? So here when you understand, if a researcher, when he inspects 1,000 boxes and he gets an average as 352, what is that 352? Is called as statistics. I'm sure now that you know the concept of the population, sample, parameter and statistics. Whatever the 352 that you have got it for the sample data, we are trying to infer to the population. We are generalizing a study to the population. Since 352 is closer to 350 with only 2 grams of standard deviations, I'm talking about standard deviation. Somebody asked in yesterday's sessions when I had logged in the difference between standard deviation and the variance, right? So the standard deviation is an absolute measure of a variance. So generally, what does it mean? It means to say that we are having companies claiming 350 grams. I have received from the sample data 352 grams. That means to say that I am indifferent of only the difference between 350 and 352 grams is 2 grams. And that 2 grams is an absolute difference. And that is my standard deviation. So in general, whatever the boxes that the company manufactures, they manufacture in between the weight of the box ranges between 350. 352 is the one that I have got it. So 2 grams of variation. So the company can say that the box that is manufactured and it goes to the market varies between 348 grams to 352 grams. So the 2 grams of plus and minus is what is called as standard deviation. I'm sure that I hope I've made the concept very clear to bring it to your simple understanding of what is population, sample, parameter, and statistics. So proceeding further, we'll take a quick activity here. I want all of you to be active in the chat box. I'll just take only 6 seconds for every answer, right? I will be giving you 4 questions on the slide, right? 4 questions on the slide. Those who are interested, you can take a screenshot of the same as well. You can think about it and think about the concept later on in your leisure time. Now, the activity is this. Decide whether the numerical value describes the population parameter or a sample statistic, right? You have to tell me whether this is a population parameter or a sample statistic. So first, identify, am I talking about population or sample? Then you can get a clarity on whether it's a population parameter or a sample statistic, right? So I'm sure all of you are ready about this. So there are 4 questions on the screen here. I'm sure all of you can see this, right? The first one, a recent survey of a sample of 450 college students reported that the average weekly income for the students is $325. I'm sure you can understand from this. Am I talking to a population or am I talking about the sample study here? What's the answer? What is the answer? The first one is a sample study. Ready? Right? So sample study I'm talking about. So it's a sample of 450 students. So what is statistic here? Statistic is $325, right? Now, did you understand this? I'm talking about the average weekly income. Average weekly income is a variable. My target audience are college students. 450 college students are my sample data, and 325 is what I'm talking with respect to a 450 students. So that's an average weekly income, and that $325 is a sample statistic. Is this clear? Yes? Okay, so the next one, average weekly income for all students is $405. Tell me, average weekly income of all students. Definitely it's a population. Why? I have not told you which students, whether it's an MBA students or graduating students or a BCom students. I have not told you. I've told you in general for all students, the average income is 405, right? Who are my target audience? Student. Right? It's a student. It's a census study. So $405 is my parameter, right? It's my parameter. And what's a variable? Average weekly income, because for an average weekly income vary from one student to another student. So it's a population study, right? Now the next one, proportion of a registered voters who voted. Proportion of a registered voters who voted. Definitely it's a population study. Suppose if I make a changes here, proportion of a registered voters who voted in a month of November, then it becomes a sample study, right? So this is the difference. The next one, proportion of a people who prefer Coke over Pepsi in a sample of a mall shoppers. So what type of a study is this? It's a sample study, right? So do we have a statistic here? I don't have a statistic, but what is my statistic variable? Sample proportion, right? Sample proportion is a statistic, and I'm checking it with respect to the Coke and the Pepsi are the 2 products which are variables. So this is my proportion of the people is nothing but the sample statistic, right? So again, I have 4 questions quickly. Let's take about 6 seconds for this. The average age of your 100 regular customers. Average age of your 100 regular customers. So again, it is the 100 regular customers is a sample study, right? Right? So regular term is a sample. So it's 100 regular customers. So it's a sample study. Next. The survey of 2000 federation members had shown that 48% believed Polish should have the right to take an industrial action. So what is this? Again, it is a sample study, right? So we have a sample survey of 2,000 members. So 48% of a sample is nothing but the sample statistics. The next, according to the survey of 606 city residents, garbage collection was the city service people liked most. So again, 606 residents are nothing but the survey of 606. There can be a large number of residents. So you are taking a survey of 606. So it is the, suppose if we say a statement as survey of all residents of a city, and they have said that the garbage collection was the better service, then it is a population study, right? Now, average income of all faculty members working at St. Aloysius College, what is it? Yes, population. Why? Why it is a population? Because I'm talking about all the faculty members, right? Faculty members, because there is some defined population, there is some defined sampling frame, and we have the average income as the parameter which can be studied. So this is how the concept of population, parameter, sample, statistics can be understood. Now quickly we'll take 2 minutes to understand what are the next two concepts, that is observation and elements, right? First and foremost thing, you need to know what is element, right? Can somebody tell me what is element? What is your understanding? There is no rule that you have to give a right answer, right? You can, we are all in the learning process. What is your understanding of an element? You can just type it out in the chat box. What is an element? Each unit in the sampling, of course, yes. So this is an element. So generally, an item for the study is what is called elements. And in research, people term element in a varied names. What are they? People call them as a subject, people call them as element, people call them as individual or sampling units. General habit of talking about a unit of a study is a sampling units or elements, right? So an individual unit is what we call it as a sampling units or elements or subjects. So in my study of industrial production, then it is a Tetley T is once every single Tetley T box is nothing but the elements. And if I'm talking about say a job satisfaction variable of St. Aloysius College employees, then every single faculty is a element, right? The next is observation. What is observation? What is observation? Observation is a value that is taken by the parameter or a statistic. For example, we set the average life of a bulb is say 5 years, right? That 5 is what is called observation. Average height of a person is a 5.9 inches. Then it is a height, the 5.9 inches is what is called as a observation. The tea box weight is 350 grams. That is nothing but the observation. But understand something, I said height, weight. Height to weight is not observation, right? Height to weight is a variable, whereas the value taken by the variable is what is called as observation, right? Now that you know the basic language of a sampling design, right? You can now easily understand the concept of sampling design, right? Now, what is a sampling? The first definition of a sampling is simply nothing but it's a process of selecting the representative. Again, I'm stressing the word representative, right? If you have defined a population, then your sample should be the representative of a population. So you take a samples and study the samples, do a statistical analysis on these samples, perform some results, and those results you generalize it to the whole population, and this entire process is what is called as an inference, and that itself is called the process of selecting a sample from the population is what is called as sampling, right? The process of selecting from the population is called as sampling. And in a day-to-day life, we all tend to make a use of a sampling decisions, cooking a rice, swab test, buying a grape, as I told you, or a fruit from a merchant, or tasting the recipes before you want to serve it to anybody at your home, or for a guest who visits your home, or a blood test. In all these cases, we tend to use a process of sampling. Again, I make a difference. Sampling and the inference, right? Sampling is a process of selecting the samples from the population, and inference or a statistical inference is a branch of a statistics where from the samples you're trying to make a conclusions to the populations, right? So this is why exactly what is the difference between sampling and the inference. But the question, why do we require sampling, right? Definitely a pragmatic reasons of budget, right? So as I told you, for any researcher, whether your research is sponsored by the major research, minor research, or anything, right? So you have certain budget, you have certain time, right? So within, you cannot take 10 years to do one research, right? That's not practical. So within the stipulated time, you must say what is the budget that is required and what is the time that you can take to investigate the samples, right? So because of the pragmatic reasons, we go for the samples and the limited access to the total population. As I told you, we may consider a universe or we may consider a population. So based on the accessible population, if you have a limited access, then it's always advisable to go for the sampling. The second is an accurate or a reliable results, right? Always samples yield an accurate information in comparison to the totality. Definitely the census gives you the better clarity information, but sample also yield a reliable result. So there is a difference between the reliability and the validity, right? So there is a difference between these two. So once you understand the concept of a reliability and validity, it becomes easy for you to understand that sample study can generate an accurate and the reliable results. The third is a destruction of a test units. Now, what do you mean by this? Right? Sampling always reduces the cost of a research in the finite population. Let us assume that I have a company manufacturing the crackers for Diwali, right? And let us say a person comes to inspect my crackers that is manufactured and wants to check whether my crackers lead to a sound pollution or the sound pollution or air pollution and so on. So they want to come and check my samples that has been manufactured. Now, as a researcher, can he burn all the crackers that is manufactured? Can he do that? Where all the destruction of a test units are done, there is nothing left in the company. So in those cases, it's advisable to go for the sampling, right? Something when your census study is not feasible or appropriate, it's always better to go for the samples. Now, what do you understand from this puzzle? You can see one picture on a slide, isn't it? So what do you understand from this picture? All of you have played the jigsaw puzzle, isn't it? All of you have played this jigsaw puzzle. So what do you think? Why exactly I've put you the 4 pictures here? Don't look at the handsome person on the picture and say he's handsome and so on. That's not the unit. That's not the thing. So, but what is an idea that you can get from this? See, when in the first case, in the first picture at the bottom right, so at the bottom right, so you have a small units of the jigsaw puzzle. Now, when you have a small units of the jigsaw puzzle, do you get a clarity of the whole picture? Do you get a clarity of the whole picture? As then when we increase the picture, as in when we increase the small unit pictures, and then we try to collect it together, and then you get the clarity of the picture. So what is an understanding here, right? These are all samples. What is an understanding here? Larger the samples, better accurate is your study. Are you understanding here? The more the sample jigsaw puzzles pieces that I get it, or a sample pieces of a jigsaw puzzle that I get it, I can definitely get a clarity on what the picture is all about, right? So this is what exactly is an understanding. See, keep in mind, it's better to go for the sample study, but at the same time, you should look for the feasibility as well, right? So to understand the sampling theory, there are 3 important laws. One, a law of central theorem, the law of large numbers, and the law of random selection. If you look at the statistics books, it takes ages to understand this concept. But let me put it in a very simple understanding. Now, all of you know, you have been exposed to statistical analysis in the last 2 days, right? So Dr. Sucharita Suresh has given you an idea about when do we go for the parametric test and when do we go for the non-parametric test, right? There is some assumption called as your data should be normally distributed, right? The central limit theorem says that as and when you increase your sample sizes, I repeat it again, as and when you increase your sample sizes, your data from skewed it moves to the normal distribution. Whether the data is positively skewed or negatively skewed, it will take a shape of a bell curve, and that is called as a normal distribution. And that is what is the central limit theorem is all about. That is, increase the more the sample sizes, more the normality of a data, right? The second one is law of large numbers. Now, what is a law of large numbers? The principle of law of large numbers says that as and when you tend to increase the size of the sample, the accuracy of the samples can be increased, right? That is, more the size of the sample, more accurate is your analysis. So that is a law of large numbers in simple terms, right? The theoretical concept is different, but I'm telling you what is a layman understanding of it. Then law of random selection. As I told you, if a company inspector comes and I give the boxes, 10 boxes, and ask him to inspect that, then the answers definitely will lead to the bias. To avoid the bias, adopt the concept of randomization, adopt the concept of random selection, right? So that's where exactly the third law comes on a sampling theory, that is law of random selection. So these are very important. That is, when you choose a sample sizes, increase the sample sizes so that you can have the normality of a data. The better the the better the data, better the sample size, the better the normality. Law of large numbers, increase the sample size to have the more accuracy of the data. Third is the include the concept of a random selection. Then you can have the more, you can avoid the bias, and it can lead to the more accuracy. Now, this is something that I want to tell you, right? We have a population, we have a sample, but something that look alike cannot be your representative samples. Are you understanding this? I'm sure this picture is very clear. I'm sure this picture is very clear. So here we have a population, here we have a representative sample, and here when we consider the tiger and the cat cannot be a representative sample for the population of tigers. Now, always a representative samples are good for you to are to be considered in a study, so that your study can be generalizable to the population. See, if you take into this consideration, if you may have a heterogeneous population, right? You cannot take a same alike people where you tend to say that they are representative samples. They are not unrepresented. They are unrepresentative samples. Based on the need of your study, if you take it also unrepresentative sample. So there is a process of selection, and that is what is called as a representative samples, right? Now we come, now understanding the basics, now that we know the basics clear, right? Now that we know the basics clear, now that we know the basic language of a sampling design, right? Now that we know what are representative samples, now that we know the clarity on the population parameter, sample, statistic, observation, and the elements, we go for the process stage of sampling design, which has 5 important methods, right? The first step is define the target population. Second step is select a sampling frame. Third step is specify the sampling units. Fourth step is choose the sampling method. That's very important. Last step is determine the sample size, right? So the first step is target population. I've already told about this, right? Identify the target population. Have the clarity on who are your representative samples who have to be for your study, right? So this clarity, the researcher should have it, so that the ambiguity can be reduced in your research. Second is your sampling frame. Know whether your population is finite or infinite. If it is finite, whether your population list is available to you or not, or we call it as a working population is available or not. For example, if I want to learn about the scooter, two-wheeler owners in a city, right? Registered two-wheeler owners in a city, I can get a record from the RTO office, right? So the list will be there, the registered two-wheeler owners of a Mangalore city, I can collect it. If you want to do, if somebody wants to do a job satisfaction study of an St. Aloysius College students, you can come and have the database from the college office, you will get it. So that is called as a working population, or we call it as a sampling frame, right? But one must also be very clear about the sampling frame errors, right? So sampling frame errors are those errors where your list says that the samples are there in the list, but in real population, they are not there, right? That chances can happen when you say that the employees have left, retired, or due to the cause of a death, there is an absence of an employees in the organization. That can lead to a sampling frame error. So you have to be little careful about the same. The next is the third step. Again, sampling units. You are very clear now what are sampling units. Sampling units are also called as what? Element, subjects, right? You are also calling them as an elements or a subjects. So you have to be very clear about the sampling units. The next important step is the sampling method. So what is a sampling method? The probability sampling method or a non-probability sampling method, right? So under the probability and I'm sure all of you know the concept of probability and non-probability, isn't it? What is probability sampling? Probability sampling is a sampling technique where I give every individual an equal chance of being in my selection. I repeat it again. Probability sampling is a technique where for every individual in my population, I give an equal chance of getting selected in my selection. Whereas non-probability sampling techniques are those techniques where I do not give the chance for everybody likely to be in my sample selection, right? Now, I'm sure these differences are very clear. Now, having said this, you can take a screenshot of this and it's available in an internet as well. So that is, there are 4 basic techniques under a non-probability and there are 4 basic techniques under probability. Now, I'm sure many of you have a confusion. When do we go for probability? When do we go for non-probability? Keep in your mind a simple understanding. The probability sampling techniques are all those techniques when you have your sampling frame in your hand. If you have sampling frame, that is, if your population is finite, then you can always go for the probability sampling technique. When you have no clarity on your sampling frame, when your sampling frame is not available to you, am I talking about infinite population? Yes. When you have infinite population, then you must certainly go for non-probability techniques. Is the clarity clear to everybody? When do we go for? Firstly, you should know what is probability technique, what is non-probability technique. Can I get a response in the chat box? Okay. So that will also tell me, should I proceed further or not? Okay. Firstly, it is probability and non-probability. Secondly, you must have the clarity on whether, when do we go for probability technique? When do we go for the non-probability technique? So when do we go for probability technique? When I have my finite population, when I have the total list of the units with me, when I have a sampling frame with me, I go for probability technique. When I am dealing with an infinite population, when I do not know how many units are there in the population, when I do not have a sampling frame, I go for the non-probability technique, right? So having said this, quickly let's understand simple random sampling. See, the word is so beautiful, simple random sampling. People call it as SRS method, right? So SRS is a method which will talk about where every individual included in the population has an equal chance of getting selected in my selection. Say, for example, I have a 60 students in my class. Right, I have a 60 students in my class. I want to pick 10 students. Now, I can pick those 10 students who are my mentees. If I'm doing that, then I'm not using a simple random sampling method. So what a simple random sampling method? All 60 students should get an equal chance of getting selected in my group. Of course, I picked 10 students, but everybody should have an equal chance. So that is called as simple probability sampling. Now, under simple random sampling techniques, the 2 basic assumptions are: 1, your population items in the populations are alike. Second, you have sampling frame readily available to you. There are 2 methods. One is with replacement, without replacement. We will not talk about it much now, but understand there are two types of methodology to do this, right? If you give me one full day to talk about only simple random sampling, I can talk about simple random. Why? Because there are various methods that you can use to derive this, right? You can use Excel, you can use an SPSS and many things, right? But general understanding is we have a lottery method and a random number table method. In lottery method, we tend to put all the name of a the sample units and then put it in the identical sheet papers, put it in the box, shuffle the box and pick 10 students, right? So that's a lottery method. But tell me, is it feasible for the large sample size? Say I have to pick from about 1,000 representative. Can I take from 1,000 population size? Can I take all the people name, write it in a chit and put it in the box? It's not feasible, right? It's not feasible. But what's another substitute for this? The other substitute for this is a random number table. Earlier, we had a biometric tables which were giving about a 5 series random numbers, 4 series random numbers, and so on, right? That was a theoretical concept. But today, we have an Excel within fraction of time, you are able to get the random, you are able to generate random numbers. How many random numbers? At 5 minutes, you can, 1 minute, you can get about 1,000 to 2,000 or 10,000 random numbers, right? You can use an Excel command called RAND and generate the random numbers. And in SPSS also you can use we have in transform a function called as RAND Bernoulli. So you can use that command and then also you can generate the random number. So this is your simple random sampling method. The second one is a systematic method. Now you may wonder, when we have a simple random sampling method, why do we have to go for systematic method, right? Simple random sampling has its own limitations. Understand this. Whether you are taking a large samples or a small samples, right? So it has its own limitations. But if your population is defined and if your population is defined with the small samples, then it's better that we can go for a systematic sampling. Now, what is systematic sampling method? Now, when you look into the slide, you may think that, oh, too many the formulas are there and so on, right? Now, let us quickly go to an examples of how do we derive this. Let us assume I have a 40 students in my class, right? I have a 40 students and I give the number identification as 1 to 40. Now, what am I supposed to do here? First step, I am supposed to understand whether I have a population frame, sorry, sampling frame. I have a sampling frame, of course, the 1 to 40. Now I have to find something called as a sampling fraction. Now, what is sampling fraction? Take a ratio of the total number of students divided by the sample size that you want to derive. Say I want to derive 8 students. This is my decided sample size, 8 students. So I take 8 students. So 40 divided by 8, right? What is 40 divided by 8? I get 5. All of you are following this, right? So I'm not giving you the holistic idea about this, what you can see on the slide, right? The formulas and so on. So I'm just explaining you with this example here. First step, I give the identification numbers. Step 2, I know my sample size I have to take is 8 samples, right? How did you decide it? That's the last step that I will come back later. Now, 8 is a sample size. What is the next step? You have to find a sampling fraction. And what is sampling fraction? 40 divided by 8 is 5, right? 5 is your sampling fraction. Now, having this 5 with you, you have to randomly select a number between 1 to 5. What is the number that you want to select? Let's say I will select 4, right? Any number of inclusive of 1 and 5, you have to pick one number. I take 4. Now that you can see here, I have firstly randomly chosen a 4th candidate because my sampling frame has said 5. Out of 1 to 5, I have used a simple random sampling method and chosen a one particular number, that is 4. Now what I'm supposed to do is, after the 4th candidate is selected, every 5th interval candidate, that is every 5th candidate from 4th is selected in my selection. So 4, the next 5th candidate will be 9. The next 5th candidate will be 14. The next, because why I'm taking 5th candidate? Because it's a sampling frame, the sampling fraction, right? So when I do this, when I finish till my last samples, of course, I have my 8 samples who are selected in my selection systematically, right? It's systematically. Again, it has its own disadvantages. It depends on or the grading that you give it. It depends on the number that you have taken, or it depends on the database that you have it, and so on, right? Keeping this as a drawback, we go for some other method for selecting the sample. So here when you say out of 40, your 8 selections are already done. Who are the 8 selection? The register number 4, 9, 14, 19, 24, 29, 34, and 39, right? So this is the systematic sampling method. The next is why first one is 4. Why first one is 4? The first one is 4 is because out of 1 to 5, because my sampling fraction is 5, out of 1 to 5, I have selected, I take one, I write it in a piece of a paper, 1, 2, 3, 4, 5, shuffle it, and randomly I have picked 4. Right? 4th candidate is selected randomly. When you take it, if you take second, then your first selected candidate will be second, then the 5th candidate will be the 7th, then the next 5th candidate will be 12, and so on. So this is how exactly you tend to select it. I'm sure I'm clear about this. Tara ma'am. Okay. So the next is the stratified sampling method, right? Stratified sampling method. Now, when you hear this word stratified, so can you, what is first thing that it comes to your mind? Stratification, what is it? Division, right? Stratification is simply nothing but division. So here we are having a groups, right? Suppose, see, people, when we say a selection, what normally people say, from all of them you are randomly selecting, but there can be a differences, right? In a group, there can be a age-wise differences, grade-wise differences, designation-wise differences, department-wise differences, sector-wise differences, experience-wise differences, and so on. So generally, Professor C.R. Kothari says that it's not that it's easy to include all of them in the group. You should get an equal representative from the strata. So to have an equal representative from the strata, Professor Kothari defines something called as a stratified random sampling technique. Now, what does a stratified random sampling does? Stratified random sampling divides the entire population into a distinct subgroups, right? So distinct subgroups. Now, who defines this? Again, under this, there are some strata is decided based on the researcher's knowledge, right? Say, for example, in a whole class, I want to divide it as I want to get an equal representative from the boys and girls. So I divide them into 2 strata. If I say that I want the boys and girls with the experiences of a say a work experiences and the study, that is as a student experiences, then I give some other sectors, right? So this is how exactly I divide the strata. Now I'm sure all of you have understood what is this, right? First 3 important questions. Once we finish the stratified random sampling, we can break, isn't it, sir?
Okay, madam.
Okay, I'll just complete the probability. Okay. Yeah, it's 6:30. So I'll complete the probability techniques and we can break and then come back and do the non-probability. Okay.
Okay.
Okay. So here the question comes is, there are 3 important questions. First, how to form the strata. Second, how should the items be selected from each stratum? Third, how many items can be selected from each stratum, right? I'm sure this was a question in your mind as well when I defined stratified sampling technique. First one, how to form the strata, right? So the first and foremost thing one must understand the elements, firstly, you should know your population. You should have the sampling frame. And then based on your knowledge of based on your knowledge of a research or keeping the objectives of your research, you can define the stratas. Say all postgraduates, under all postgraduates, I will segregate the people as a masters in one strata and PhDs in the second strata, right? So I have a 2 stratas here, right? So what is an understanding here? The elements within the strata should be homogeneous, but across the strata, they should be heterogeneous. I'm sure you are able to understand homogeneous. Homogeneous are with the similar characteristics. Heterogeneous are with the indifferent characteristics, right? So this is how do we form the strata. The strata that you form should have all the people within the strata should be having a homogeneous characteristic, whereas between the strata, if you compare strata 1 and 2, they should be heterogeneous. They should be different. So this is how do we form the strata. Now, once the stratas are formed, the next step is to select the items from each strata, right? Now, how do you select the items from the strata? You can apply a simple random sampling method, or you can apply a systematic sampling method. Now, the rule, is it that we have to, if I'm saying I'm using a stratified sampling, I always have to adopt only one method? No rule. It's up to the knowledge of a researcher. You can mix and match between the techniques that you have understood from the sampling theory, right? Then we have the third step. How many items should be taken from each stratum, right? That means how much of a sample should be taken. Now that you have a clarity that the entire population is divided into strata, the people from each strata are selected either by simple random sampling or systematic sampling. But how many people has to be taken from each strata? That is important to understand, isn't it? So that can be done by two techniques, which we call it as proportionate stratified sampling and disproportionate stratified sampling, right? So we have two methods. So what is proportionate and disproportionate? I have an example on the slide for you here. So proportionate sampling, say for example, I have the categories of my students, say let's say 1,000 students here, and I have categorized their grade as low grade, medium grade and high grade, and I have 700 students under low grade, 200 students under medium grade and 100 students under high grade. Now, did I put them under three strata here? Strata 1 is low grade, strata 2 is medium grade, and strata 3 is high grade. So they are all belonging to one population. I have a complete list of them is 1,000, right? Now, the people within the group are homogeneous, but people between the groups are heterogeneous. Do not get confused. Low grade people, all these 700 people who are belonging to the low grade are all homogeneous. The low grade people, and comparing them to the medium grade people, they are heterogeneous, right? So with respect to any type of a scores that is being taken into consideration. Now, how do we select the samples? How did I get this 70 here? How did I get this 70? I'm talking about proportionate stratified sampling. When I say proportionate stratified sampling, I need to take a sample in proportion to my population. 700 divided by 70, 200 divided by 1,000, 100 divided by 1,000. What is the value that I get it? 70, 20, 100. So am I taking 10% of my population? Of course, yes. So this is a proportionate stratified sampling method, right? Now, what is a disproportionate stratified sampling? I've given another example here. Let us say I have a bank having a 10,000 customers in the bank, right? That the bank divides the customers into three strata. Who are the three strata? Big account holders, medium account holders, and the small account holders. Did you get a clarity of a strata? The people who are all belonging to the big account holders are all homogeneous in nature. But between the groups, they are heterogeneous, right? Within the groups, they are homogeneous. But big account holders are, and medium account holders and small account holders, between them, they are heterogeneous. Now tell me how much should be quickly type it in the chat box. How much should be the samples should be taken from the big account holders? If I have to choose 100 people, 1,500 divided by 10,000 multiplied by 100. So it is 15, right? So 1,500 divided by 10,000 multiplied by 100. So I get the answer as 15, 35 and 5, that is 50. So this is my sample size, right? 15, 35 and 50. So this is the sample size that I have to take it. Understand? What am I doing? I'm taking samples in proportionate to my strata size, right? I'm taking samples in proportionate to my strata size. Now get back to my second one, disproportionate stratified sampling. Now, if you have a simple, see, we call a Bible of research methodology is your C.R. Kothari textbook, right? Business Research Methods by C.R. Kothari. C.R. Kothari beautifully explains it's not that always you should go for the in proportionate to strata size, because there is something called as a variance. There is something called as a standard deviation, right? Standard deviation is very important, which is always linked with your average. So, C.R. Kothari says that you should find something called as a weights, right? He gives something, he says that if you have to take a samples in proportion to the population, then they have to be dependent on the weights. Now, let's say, how do we consider it? Say, This is my strata size that I had it, and I calculated the standard deviation. My standard deviation is simply nothing but my sigma. If they are 5, 5, 6, right? Where the marks are 5, 5, 6, and very minimum and nominal variance, it's still advisable. CR Kothari says you go for proportionate sampling because the variance is almost same. If suppose the variance is different, in the first case, I have given you for low category, it is 10, for medium is 5, in height is 2, the high is 2, then if you take a proportionate, then it is an error, right? Understanding this, right? If you take a proportionate sampling here, then it is an error. So what you're supposed to do is you should find the weight, right? Now, how did you find the weight here? Firstly, I have multiplied 700 with 10. You can take a screenshot of this and then analyze it in detail later on. 200 into 5, 100 into 2. So the total sum will be 8,200, right? So this should be divided, 700 divided by 8,200, multiplied by 100, you get 85%. So this is a weight, right? 85% means out of 100, it will be 85 samples. So this is the samples. What is sigma? Sigma is a standard deviation. You can get this sigma from your SPSS options called compare means, right? When you go for compare means and when you put for the variable marks, you will be able to get the sigma. Sigma is standard deviations, right? Sigma is standard deviations. Now, CR Kothari also says, suppose if your variation is in the reverse, that is low as 2, medium as 5, high as 15. Again, a proportionate sampling will be an error. And he says that it's always better to go for the weights and then consider the sample sizes, right? So this is the clarity that I want to give you when you have the standard deviation. No, don't simply take a strata size and find the samples. So always a strata size should be found compared with the standard deviation, and then you can decide the number of samples to be taken for each strata, right? So this is your stratified sampling. The last one quickly we will discuss, that is cluster sampling, and then we can break. So the cluster sampling, people tend to get confused with the cluster sampling and the stratified sampling, right? So understand the difference. Again, you can take a screenshot of this. The cluster sampling and the difference is very, very clear. I'll make it. See, this is with my experience that I have got these differences, right? No textbooks you can find these differences, but understand the basics of it. I explained this same concept for you in stratified sampling, isn't it? So what happened in stratified sampling? Between the samples, they were all different, right? Within the samples, they were same. Low, within the strata, they were all same. Between the strata, they were all different. But what happens in cluster sampling? Cluster sampling, it's a reverse. Between the samples, they are same, but within the samples, they are different. Now, how did you understand this? Say same marks of 700 students, I'm dividing them into 10 groups. First 70 students in the first group, second 70 in the second group, third 70 in the third group, and so on. When you take a sum total of this, I get 700. Similarly, medium, first 10 to 20 in the first group, second 20 in the second group, and so on, right? Now, what did I do? I have not divided them on a strata, but I have divided the same 1,000 students into different clusters. Right? So between the clusters, the samples are all same, but within the clusters, they're all different. Are you understanding this? Between the cluster C1 and C2, the samples are all same. 70 students, and so on. But within the clusters, they're all different, right? So this is the basic understanding of cluster and stratified sampling. But the logic here, when should I go for a cluster sampling? Generally, people call this as an area sampling. People call this as a geographical sampling and so on. Why? Because it is easy for a researcher to divide the large geographical area into different clusters, right? That's why people call this as a cluster sampling. I will bring another example for you. With this, we can stop for and break for a while. So one is, if I suppose a researcher wants to interview a Bank of Baroda branch managers from Dakshin Kannada using a cluster sampling. So firstly, what the person has to do, he has to get the Dakshin Kannada map, right? So divide the Dakshin Kannada into a 5 taluks, but now it is more than 5. So if suppose we consider this as a first cluster, second cluster, third cluster, fourth cluster, fifth clusters, and so on. Now in a first cluster in Mangalore, how many Bank of Baroda branches are there? There are many Bank of Baroda branches. How many managers are there? There are many managers are there, right? So these clusters are homogeneous in nature, but within the clusters, the branch managers are all heterogeneous in nature. Then the selection of these people can be done either a simple random sampling technique or using a cluster random, simple random sampling technique or a systematic sample technique, right? So this is another example of a sampling technique under cluster. Again, you may think, what is one stage, two stage, and multi-stage? If suppose in a first stage, if I'm selecting a states, then it's a first stage of cluster sampling. From the selected state, if I'm selecting a districts, then it's a second stage. From the districts, if I'm selecting the taluks, then it's a third stage. You can define based on our research, based on your research, you can take up a call, right? So that is your cluster sampling methods. So shall we break for 15 minutes, sir?